All right, welcome back to part 2. We're going to look at division, which is a lot more complicated. I have even had to put a smiley here to indicate that. We can start off by dividing by I itself. And if you take into account that I is the square root of -1, then rationalizing the denominator means I just got to multiply by that square root. And of course, when it's a fraction, I want to multiply by 1 still, right? So I've got to change the denominator and the numerator, and then we get -1 in the denominator, and we have the square root of -1 at the top. So it actually turns out the 1 divided by I is -I. Isn't that interesting? But what about this guy here? Okay, this isn't just a simple I here. Which bit do I divide by, etc., etc.? So that's why this thinky face is here. So to do this, we're going to learn a bit about the complex conjugate. Okay, and this is described here. My complex number Z is some real number plus a real coefficient of I. And its conjugate, notified by this hat on it, this straight hat, is exactly the same, except we subtract away that coefficient of I. So the question is, why? Well, I want you to think about surds again. So you might have seen this before. If I had 3 divided by the square root of 2 plus 1, if I multiply by 1 still, but root 2 minus 1 divided by root 2 minus 1, we end up cancelling out the bottom surd, okay? And that's by difference of perfect squares. In case you forget, a minus b times a plus b gives me a squared minus b squared. So that cancels it out, and we've still got the 3 times root 2 minus 1 here. And, well, 2 minus 1 is 1. And so we end up with 3 times root 2 minus 1. That's what this is over here. If you put this in your calculator and this in your calculator, you'd get the same answer, even though they look so different. So we said when we're working with surds that root 2 minus 1 is a conjugate of root 2 plus 1. And that's what it meant, okay? But I'd also like to note that 1 minus root 2 is also the conjugate. Let's experiment with that. Root 2 plus 1 can be rewritten as 1 plus root 2. And if I multiply it by that conjugate, difference of perfect squares gives me this, and that equals -1, right? So let's start off with the fraction we had before and multiply it by this conjugate. We multiply the 3 by the numerator, and we know by what we've already done that this is going to be -1. It might look different at first, but when you multiply through the -1, we do end up back at the same place. So this is the concepts of conjugates that you've already learnt with surds. We're going to now apply that with complex number division.